Hi and welcome to video 17 on this Unit 4 Topic 2, Specialist Mathematics, Newton's Laws and Forces topic. We're looking at a final example in this video series and in this topic, and we're looking here at variable forces but under force systems, and so we have a variable acceleration, not a constant acceleration that we're used to. So we have a particle, which is quite a large particle if it's got that mass, but anyway, straight line, smooth horizontal table, p is the distance in x meters, and the force, it has an overall force of 16 over 5x squared newtons away from O in the direction OP. Initially P is at a point 2 meters from O and is moving towards O at 8 meters per second. So that variable force there is 16 over 5x squared. So this is going to be a little bit trickier that we're going to have to deal with. So first of all, we know that force is equal to 16 over x squared. We want to find a distance of P from O when P first comes to rest. So we really want to find, first comes to rest means we know the velocity, we want the distance of the velocity. So we want x as a function of v, but probably what we're going to end up with is v as a function of x that we can rearrange. So that's what we're looking for. Now if we have force as a function of x, and I'll zoom in on this now, it means that we have ma equals a function of x, but we know m. So m is 0.1a equals 16 over x squared. We divide by 0.1 and we get a is 160 over x squared. So we know a fair bit of information about this system, and we can solve this system now. So I'm going to use one of our relationships, and that is that A is equal to V times dV dx. That's one of our variations of acceleration, and it's on the formula sheet. So we get V dV dx is equal to 160 over x squared. This is really good if we have acceleration in terms of displacement, because now I can integrate V dV as the integral of 160 over x squared dx. So we know the interval of velocity is equal to half c squared, which looks suspiciously like one of our other variations, so we could have used that. And if we integrate this, we get, this is 160, I'll just write it over here, x to the power negative 2, and when we integrate that we get 160 x to the power negative 1 over negative 1. And that's equal to negative 160 x to the power negative 1 plus some constant that we've got there. And now I'm going to separate that to get v squared is equal to negative 320 over x plus some constant. And we'll deal with it in that way. And there's still some variations here. And we know our initial conditions, or at least a condition. And a condition up here is that P is at 2 meters away from O and has a speed of 8 meters per second. And it is initially, which we might need later on, but let's just start with that. X equals 2 when V equals 8. So we get 8 squared equals negative 320 over 2 plus C, which means that 64 plus 160 equals C, and therefore C is equal to 224. So V squared is equal to negative 320 over x plus 224. So that's an important piece of information, and it's this situation, because if I had a different rearrangement I'd get a different C value, so you need to keep that in mind as well. But that should work for this one. Now I want to know what happens when velocity is 0. So at v equals 0, I get 0 equals negative 320 over x plus 224, which means that I get x is equal to 320 over 224. And that, of course, is 2/3 of a meter. Now, I don't know the direction of this, but I have got that negative 320, and when I take the 224, it becomes positive. So it's a positive direction, but I didn't really do a great job of defining my direction earlier. So it's positive direction based on this 2 value up here that I substituted in earlier. So it's 2/3 of the distance towards where that 2 is as well. And there's our answer. All the best.